Thank you. I'm going to present our work on dynamic contrast enhanced CT imaging for small animal. The motivation of this work is clear. Having a quantitative perfusion information in rodents can be very useful for preclinical studies. And the conventional way to obtain this information is to reconstruct 3D images at different time points during the wash-in and wash-out of the contrast. This is unfeasible for slow-rotating small animal scanners because all the, let's say, interesting stuff is happening within just one rotation. So we end up actually with inconsistent projection data set. You can see here an example, and these are projections at different angles, and you can see how they come from a different contrast distribution. So the goal of this project is to substitute this question mark here with hopefully nice time curves. For this, we need to optimize the acquisition in order to obtain the best data set possible from such scanners. And then we need to find ways to reconstruct that data set. And we divide our work on reconstruction in 3 main lines. And one is focusing on the inconsistency of the projections. And in here, we propose to model the unknown data with a 3D plus T model and reduce the dimensionality by modeling time with just a small number of basis functions. So we can obtain these basis functions that we have here by analyzing planar studies, planar contrast enhanced studies, and then we include those functions into the system matrix. And finally, we use an algorithm to obtain the coefficients for each basis function at each voxel position. On a second line, we're trying to optimize statistical reconstruction for low-dose CT and improving the projection model. And finally, and this is a very recent line, we're still starting, is taking into account the sparsity of the data we have, just explore the compressed sensing approach to solve this problem. We have presented several results on the first two lines of research, both 4D reconstruction and a new algorithm, a statistical algorithm with a better projection model, including the polyenergetic nature of the X-ray source. And all these are steps towards the final goal, which is to have a small animal CT with dynamic contrast enhanced capabilities. On our wish list, we would like to have potential users that will help us to evaluate and also to improve our methods. Also, we're eager to collaborate with people working on reconstruction, especially for CT, and also any compressed sensing reconstruction for any modality. And also, we would like to explore the possible extension of this same approach to motion correction in such scanners. That's all. Thank you very much for your attention. And I would also like to mention that we have more preclinical work on a poster that you're welcome to check out. Thank you. Thank you.